Welcome to the lecture on the reference angle. The reference angle theta caret is the acute and positive angle between the terminal side of theta and the x-axis. And it will become important among other uses when we when we calculate inverse trigonometric functions on the calculator to determine the angle, and what the calculator will give us in all likelihood is just the reference angle, and then we have to see in what quadrant we are and have to add or subtract that reference angle. In any case, let's start out here. As an example, name the reference angles for theta equals 30 degrees, 135 degrees, 240 degrees, and 330 degrees. And we can just quickly look at them and say, okay, 30 degrees, that's 30, of course. This one here will be 45 degrees. This here will be 60 degrees. And this here will be 30 degrees again. Did that off the top of my head because I'm familiar with it. So instead, let's go to this website here and look at it a little bit more in detail, and I believe it's going to look easier to us. Okay, here's a website that talks about angle measures and the reference angle. So I'm going to go over here. The first one was 30 degrees. So we are here. You can see it says pi over 6 here, and here it says 30 degrees, and the reference angle is also 30 degrees. We're in the first quadrant, so the reference angle theta caret is the same as the original angle. The second one said 135 degrees. Remember I said 45 degrees is the reference angle, so I'm going to go over to 135 degrees right there. You can see 135 degrees. The reference angle comes out to 45 degrees. It's measured between the x-axis and the terminal side of the angle, and that's what I had mentioned a moment ago. 240 degrees, so we go over here. 240 degrees. As you can see on the circle, there are the angles in radians, and then up here it shows in degrees. So here we have 240 degrees, and then we have a reference angle of 60 degrees, again measured from the terminal side to the x-axis. And then we have 330 degrees, so we're going to be over here. And we have a reference angle of 30 degrees, as said, always positive, acute, measured to the nearest x-axis. With that, we can go back and write down the results. So of these four angles for theta caret for the reference angle, it's 30 degrees, 45, 60, and 30 degrees. Okay, let's go ahead a little bit. A trigonometric function of an angle and its reference angle differ at most in sign. So we have sine 30 degrees, which since 30 degrees is the same as its reference angle, we also come up with sine of 30 degrees, and we know that the answer to that is 0.5. Here in this diagram here, I have 30 degrees right here, and then it determines the sine, which is this one here, and if the hypotenuse is too long, not too long, but TWO, the hypotenuse has a length of 2, and the opposite has a length of 1, then of course we come up with the sine 30 degrees is 1/2. Okay, sine 150 degrees, which goes from here to here, and the reference angle of course is 30 degrees. So this here will be again 30 degrees, and now we have to pay attention that we're in the second quadrant where we have reference angle of 30 degrees still, and we have to look at, well, they differ at most in sign, so we have to look at, is the sign positive or negative in the second quadrant? In fact, of course it's positive, so again we come up with 0.5. In the third quadrant, at 210 degrees, we go from here to here. Again, we have a reference angle of 30 degrees. now we're in the third quadrant, and now this definitely applies. It differs at most in sign, and we know that the that the sign is, that is S-I-N-E, is negative in the third quadrant, so we need to put a negative in front of that. And so it's going to be negative 0.5. I'm going to see if I can grab a negative, a nicer looking negative here somewhere. There we go. So there it is. Okay, and the third one would be 330 degrees. So we go all the way around here to the terminal side, 330 degrees. Reference angle again is sine 30 degrees. And then we're in the fourth quadrant, so we have a negative in front of that, and we again come up with negative 0.5. Okay, similar for the cosine. Of course, for the cosine, I may want to look at the adjacent rather than the opposite. So here for the sine, we have a +1 and a +1 and a -1 and a -1. Well, for the cosine, if we did that, we would here have, for example, if I adjusted the length here, a +1 here and the -1 over here. Okay, let's do some examples. And again, I'm going to go to a website where we look at these. Not this, but this one. And it says, find the exact values for sine 240 degrees. We pretty much know that the reference angle is 60 degrees for that one. Oh, I actually have it in this position here already. And the sine of 60 degrees, of course, comes out to the square root of 3 over 2, or 0.866. And we're in the third quadrant, so we need to put a negative in front of that. Tangent of 240 degrees, so again I put it at 240 degrees right there. And then I click on tangent. And then it says 1.791, which is the square root of 3. Well, our reference angle here, the diagram doesn't show the reference angle, but this would be a reference angle of 60 degrees. We know tangent of 60 degrees is 1.791, and then we have to pay attention to that. We're in the third quadrant, so it's a positive as well. Cosecant of 300 degrees. So here, 300 right there. Right there. There we go. For the cosecant, the reference angle here at 300 degrees would be 60 degrees. The cosecant of 60 degrees is the reciprocal of the sine of 60 degrees. We know that's the square root of 3 over 2. So cosecant of 60 degrees is 2 over the square root of 3. Which I do this on the side here, comes out to 1.15, and then we have to pay attention that we're in the fourth quadrant, so it should be a negative 1.15. Let's see. Okay, negative rounded 1.16. On your calculator, you actually come out with 1.154 or 5 actually. The applet must not be absolutely exact. And then the last one that I have on the list here is the cosine of 495 degrees. Well, 495 degrees, go around, so I'm at 360, I'm at 450, and now I would be at 495 degrees. So I have a reference angle of 45 degrees. I know that the cosine there is 0.707. And I'm in the second quadrant, so I know it's going to be a negative 7.07. 0.707. Let's go back and enter those results. So here is what we said, that this comes out to negative sine of 60 degrees and negative 0.866. Here we're going to come up with positive tangent of 60 degrees and positive 1.791. I put the positive in front here to point out that this is associated with the quadrants. Of course, we don't have to write positive here. That just makes it look nicer. Hey, we're in the third, I'm sorry, did I say fourth? I meant third quadrant. That we're in the third quadrant for the tangent here, and it needs to be positive. Cosecant 300 degrees is the same as the cosecant of 60 degrees. Let's see, cosecant 60 degrees. And we're in the fourth quadrant, so it needs to be negative, and we come up with a negative 1.155. And for some reason I didn't write down the negative on my sheet here, but that's correct, right? Cosecant, yeah. Okay, and cosine 495 degrees is the same as the negative cosine of 45 degrees, negative cosine of 45 degrees, which is negative 0.707. Okay. And the last thing to do is to go the other way around to determine the angle. Here it's important when determining an angle by using an inverse trig function on a calculator, only the reference angle will be obtained. So let's see what we come up with here. This one here actually should be expressed as follows. This shouldn't be theta, this should be theta caret on this one. So let me borrow one here. So sine theta equals negative 0.5592 in quadrant 3. So we determine what the reference angle is. So we take the inverse sine of 0.5592. Notice we dropped the negative. So I'm going to do that on the side here, and then a moment ago I will show you. I just don't want to switch forth and back right now. I have to make sure that my calculator is in degree mode. I think that's what we're operating here in, is degrees. I come up with pretty much 34.0 degrees. So 34.0 degrees, or a degree sign somewhere here. Okay, now I have to see that I'm in quadrant 3, so theta equals 180 plus 34, which is 214 degrees. Okay, here I might as well prep myself for the others, and we'll go to the graphing calculator in just a moment. Let's see, might as well do some of this here already. Usually I do that before class, but this time I missed that part. Okay, I'm going to go over to the graphing calculator. All right, the first one that we had was take the inverse sine of 0.5592. Come up with 0.59. Well, that can't be. 0.55 is in the neighborhood of 0.5, so we should be at roughly 30 degrees, which means my mistake here on the graphing calculator. And I point this out on purpose, because you might as well do the same mistake, is in the mode. We're in radians, but we're supposed to be in degrees. So what I just did was on purpose so that you can be reminded that you may have to double check the mode. I'm going to do second entry. And there we go. That's just like we predicted. 34 degrees. We're in quadrant 3, so we come up with 180 plus that reference angle, 214.0 degrees. I need to write that on the side here on my lecture notes. Okay, next one says tangent theta equals negative 0.8541 in quadrant 4. So we're going to take the inverse tangent of 0.8541 after 40.5 degrees. We are in quadrant 4, so we have to subtract that from 360 degrees. And our answer is 319.5 degrees. Next one is sine theta equals negative 1/2 in quadrant 3. So we take inverse sine of 0.5. 30 degrees, we're in quadrant 3, so we add 180, which is 210. I saved myself the trouble of plugging it in here. The next one is going to be the secant of theta equals 3.8637. So that's the secant, so we have to look at the cosine. That secant is 1 over cosine equals 3.8637. So we're going to do inverse cosine of 1 over 3.8637. And we come up with a reference angle of 75.0 degrees. And we're in quadrant 4, so it's going to be 360 minus that answer, 285 degrees. Just to double check, our original was 3.8637, so I'm going to do a double check with 1 divided by the cosine of 285 degrees, and indeed we come up with 3.8637, the original given one. The last one here is cotangent theta equals negative 1.6003. So we're going to do the inverse tangent of 1 over 1.6003. We're dropping the negative. So we come out 32 degrees as the reference angle. And then theta comes out, it says we're in quadrant 2, so we subtract that from 180. There we go, 148 degrees. Okay, let's go back to Word and plug in these answers. And then we're going to be done with that, with this lecture. So let's see, we have here that this one is going to be, maybe I just copy all of this here and then just do this here. Tangent of 0.8541 equals, let's see, how much did we have here? 40.5 degrees. 40.5 and 319.5. And here we have inverse sine of 0.5 equals, of course, 30 degrees. And then we're in quadrant 3, so that equals 210 degrees. Here we have Well, this one is going to take a little bit longer. The reference angle is going to be the inverse cosine of 1 over 3.8637. 1 over, of course, because the cosine is the reciprocal of secant. And we came up with 75 degrees. And we're in quadrant 4, so it's 360 minus 75, which is 285 degrees. And the last one is going to be the inverse tangent of 1 over 1.603, again, because we're using the reciprocal of the cotangent, and we came up with 32 degrees, and we're in quadrant 2, so 180 minus 32 degrees is 148 degrees. And with that, we're done with the lecture on the reference angle.